So in today's class, we are going to discuss about searching techniques. So as per our syllabus, the next content is recursion content. The recursion we will discuss later. Okay, so how to solve the recursive problems with GCD using recursion, factorial using recursion, Fibonacci using recursion. So the recursion topic we will discuss little later. Since you are already comfortable with the searching and sorting techniques, so we will first complete the searching sorting techniques. So in today's class, we are going to discuss about searching techniques. In searching, there are three major types of searching techniques available: sequential search, binary search, and hashed list search. In this, first we are going to discuss about sequential search. Okay. So what is this sequential search? You might have already implemented the sequential search concept in your C and C++. So if there is a array of elements, okay, if the array of the element is not in sorted order, okay, if it is unsorted array means we have only one option to find the given target value, whether it exists in the array or not. So that we need to use the sequential search. Okay, the sequential search is used to find a given element, whether it exists in the unordered or not sorted order, unordered array or not. Okay, so this is the sequential search. Searching is the first. Why we need to study about the searching means in most of the computing problems, mostly we will do the searching operation. Okay, so yeah, whenever we are giving some value, so even in our day-to-day real world scenario, we will use the searching concept, searching for the PNR number. So you will enter your PNR number, the ticket, its a status. So the PNR number will be searched by the inquiry system, and if the PNR number exists, then it will return the details about the PNR details. The same way, checking whether trains available between two stations. So in most of our day-to-day life, we will use the searching concept. So we should understand how the searching process is implemented in the computer. So that's why we are studying about this searching concept. Okay, so in searching we have sequential search and binary search, two concepts available. So sequential search, when we will use means if the search space, if the number of elements to be searched is small, and if it is unordered, then we can use the sequential search concept. Okay, so to perform the sequential search, normally we will have a list of elements to be searched and the target value. Okay, the value to be searched in the list, and if it is exist, then we need to return the location, in which location the data is available. Okay, that we need to return. So this is the sequential search process. Okay, so normally in sequential search process, search process, not whether it is a sequential or binary, it doesn't matter. So always, what is the objective of a search means it should return whether the search is successful or failure. If successful means it should return the index position of the target value in the given list, in which index the target is available. So index must be returned. Suppose if it is not, if the search is failure means the failure or success, okay, that can be identified using the return value of the search algorithm, either true or false. If the algorithm returns true, then the index value, the location contains the index of the target value in the list. If the search is false means then the element is not available in the list. So this is what the meaning. So this is an example illustration for the sequential search success scenario. Okay, so how it will work means it will take each element. Okay, first element in this scenario, the element to be searched, the target value is of 14, and the search process, how it will start means it will take the first element and checks whether it is equal to the 14 or not. If it is 14, then its index value will be returned. But in this case, the 4 is the first element. It is not equal to 14, so it will go to the next element. Next element is 21. Whether 21 is equal to 14 or not, we need to check. If it is not, so we need to go to the next element and check. Next element is a 36. It is also not equal to 14. So go to the next element. Next element is a 14. Yes, the third element is the 14. So it is equal to our target value 14. So we need to return 3. 3 is the location of the target value. Okay, so this is a example illustration for the successful sequential search. Suppose if the element is not available, what will happen means the same way the third element is not equal to, and fourth element not equal to, and fifth element not equal to, like that we need to search till the end of the list. Okay, if the till end of the list also, if the matching element, the target is 72 here, if it is not exist in the list means the search will be completed with false as a return value. Okay, since the element is not available in the list, the algorithm will return false. So this is an example illustration for the unsuccessful search. Okay, here in this picture all the steps not explained, but we are searching till end of the list, and till end of the list the 72 target item is not exist in the list, so this search is unsuccessful, so the algorithm returns false. So this is a illustration for the unsuccessful search. Okay, now let us discuss about the algorithm, how to implement the sequential search algorithm. The sequential search algorithm, okay, so this algorithm it identifies two things. What are things means? First, whether the algorithm should tell whether the searching data, the target data, exists in the array or not, exists in the list or not. The second, if it exists, then what is the index position of the target data? So these two details must be returned by the algorithm. Okay, and the algorithm will take 4 parameters. Okay, so what are the 4 parameters means? The list, okay, in which we need to perform the searching operation, the input array, that is the first parameter. The second parameter is the index of the last element. Okay, so like size of the array, how many elements are there in the array, so that is what the second parameter. And the third parameter is the target value to be searched within the list. Okay, and the last one is the address where the found elements index location is to be stored. Suppose if the target element exists in the list, its index we need to store it in some location. That location is the 4th element. This is the reference value, call by reference. Okay, so we will pass one variable. In the variable we will put the elements index value. So these are the 4 parameters required to solve this problem. Okay, and finally the algorithm returns true or false. If the search is successful, then the algorithm returns true. If the search is unsuccessful, then the algorithm returns false. Now this is the algorithm. So whenever we are writing algorithm in this course, so we have to follow all these steps. First, header means meaningful algorithm name. Here what is the algorithm name? Sequential search. And the parameters, list, last, target, and location. Okay, and what is the purpose of this algorithm? Locate the target in an unordered list of elements. What are the preconditions? The list must contain at least one element. The input array, it must contain at least one item. Okay, and the last, it is the index of the last element in the list. And target, it contains the data to be searched. And finally LOCN, location, it is the address of the index. Suppose if the element, if the target value found in the list, its index value, that we are going to store it in the LOCN. Post condition, once the algorithm successfully executed, what we are going to get means if the element found, index of the searched element, it is stored in location and returns true. If the element not found means we'll return false. Okay, what is the return value at the end? Found means true, otherwise false. Okay, and algorithm set looker. Okay, it is an iterative statement. Iterate means iteration variable. Iteration variable, instead of giving it as a I, J, K, some meaningful name we need to give. So here we are using looker. Okay, looker to 0. We are assigning 0 to the variable, iterative variable. Then looker is less than last. Okay, we no need to search beyond the last index value. So that is the first condition we are checking. And the second condition is the target value that we need to search. Okay, whether it is equal to the array of looker, means list of I, like that list of looker. Okay, we are comparing each elements the each element of the list with the target. Okay, if it is not equal, then we are incrementing the looker value. Okay, suppose if it is equal, then the loop will exit. Okay, and assigning the looker value to the location. Okay, and we are checking if the target is equal to the list. Okay, the loop may terminate in two cases. The first case is if the target is equal to the list value. Okay, if the list contains the target, then the loop will exit. Or when the looker is more, it becomes more than the value of a last index. Okay, then the loop will exit. Okay, if the looker value is more than last, means what is the meaning? The element is the target value is not available in the list. Okay, so that condition we are checking here. If the target is in the list of looker, then set found equal to true, else set found equal to false. Okay, so this is the algorithm for the sequential search. Now let us take an example. See here, the same algorithm here we implemented as a C program. Okay, the same algorithm, integer looker. It is a function. The function, we are passing 4 parameters: a list of array, a last index of the last element, target, the element to be searched, and pointer variable, location. Okay, if the element found its index, we will store it in the location. Okay, and we are initializing the looker value to 0. We are using the while loop, while looker less than last and target less than list of looker. Okay, not equal to list of looker, incrementing the looker value. Finally, we are storing the looker value in the location. What we are returning here means target equal to looker. Okay, if the target value and the list of looker, okay, if both are equal to, means it will return 1. Okay, it will return 1 means true, otherwise it will return 0. 0 means false. Okay, so this statement can be written like this also. Okay, if target equal to list of looker, then return true, return 1, else return 0. Okay, instead of writing this 4 lines of code, here we are writing one simple code. Okay, so this is equivalent to this 4 lines of code. Okay, so implicitly first this expression will be evaluated. The evaluated expression will give 1 or 0. That 1 or 0 will be returned. Okay, so these 4 lines of code is not required. Now in main function, we are creating an array, then n value, the number of elements, then target and location. Okay, we are calling the function. Okay, now the target to be searched is a 40. 40 is in the index position 3, 0, 1, 2, and 3. Let us check the output. See here, 40 found at index 3. Okay, suppose if I'm giving the value which is not exist in the list, I'm giving the target to be searched as 100. Now let us compile the program and execute it. See here, 100 not found in this list. Okay, so this is a sequential search. Okay, this is sequential search. In sequential search, we have 3 variations. Just to improve the efficiency of the sequential search, these variations introduced. What are these three useful variations means? The sentinel search, probability search, and ordered search. Okay, so now if you are checking in this sequential search in this algorithm, here in the loop we are checking 2 conditions. What are the 2 conditions means? Whether the looker crossed the last element. Okay, the looker is less than last. This is one condition, and the target is not equal to list. This is second condition. Okay, why we are checking this second condition means we don't know whether the target is exist in the list or not. Okay, so here what we can do means instead of doing performing the two conditions, we can reduce it into one condition. Okay, reducing condition number of conditions also will improve the efficiency of the algorithm. Okay, so how to reduce the number of conditions? Instead of two conditions, how to use it one condition? So that is what this sentinel approach. Okay, in sentinel approach what they are doing means the target element, whatever the element we need to search, that directly inserted into the list. Okay, we are storing the target element at the end of the list. Explicitly we are storing. So for sure the target element to be searched, it is in the list. Okay, so whether the target element in the is exists in the list or not, that condition we can eliminate. Okay, so we are introducing the element to be searched, the target element in the list at the end of the list, last as a last value we are storing it. Okay, so we need to search only the looker value alone. Okay, so uh, the looker value alone we can take care here. Okay, now see here, this is the modified algorithm. Okay, so here, the same algorithm, list last target and location. See here, set list of last plus one. As a last element of the list we are storing the target value. Okay, and in the iteration we are checking only the target not equal to list. So we are not checking whether the list is less than or equal to n. Okay, why means for sure the last element is a target value. Okay, the loop will terminate at the end by default. So the looker is a less than n. Okay, that condition we eliminated here. Okay, see here in this place, in algorithm in this place we eliminated one condition. Okay, when this loop will terminate means if the target value exists before the last element, then also this loop will exit. Suppose the target value not exist in the loop. Okay, we explicitly inserted as a last value in the loop. So in such case also the loop will terminate. Okay, when the looker becomes more than the last, then the loop will terminate. Now if looker is less than or equal to last, what is the meaning of this element? Means the element, the target value found before the sentinel value itself. So we are giving set found equal to true and set location equal to looker. Okay, suppose if the looker value is greater than last, what is the meaning? Means the loop terminated because of the sentinel value that we introduced. So in such case we need to it means that the element not found in the first n values itself. Okay, we are assigning found equal to false and the location equal to last. Okay, so this is a sentinel search. We are explicitly introducing the target value in the list and we are reducing one condition. Okay, this will improve the efficiency of the sequential search a little bit. Okay, and what is the second variation? Means probability search. So in probability search what we are doing means suppose if element is searched frequently, in such case we are trying to increase its probability. Okay, so suppose if an element is searched, okay, next time we are changing its position one position ahead of the beginning. Okay, suppose first time if the element is searched in the fourth index, okay, before the next search that element will be moved to the third index, and whatever the value in the third index that will be moved to the fourth index. Okay, next time suppose if the same element is searched from third, its location will be moved to second. So at the end of some 4 or 5 searches, what will happen means whatever the elements we are searching more frequently, that elements will come to the beginning of the search and the least searched items will go to the end of the list. Okay, again this will improve the efficiency of the algorithm little bit. Okay, in the sequential search itself, we have three variations of sequential search. The first one is a sentinel search, the second one is probability search. So in probability search, we are increasing the probability of most frequently searched items, okay, searched elements. So this is what probability search. The third one is a ordered list search. What is ordered list search means? In in ordered list search, the elements will be in order, okay, sorted order. Okay, sorted order means mostly it's better to go with the binary search, but still, suppose if you wish to introduce the sequential search means, we can introduce it in the ordered list. Okay, what is the advantage of using ordered list? Sequential search means we need not perform the searching operation till the last element of the list. Why means, once we find an element which is greater than the element to be searched, suppose we have a list 1 2 3 4 5 6 7 up to 10. Okay, and suppose we need to search, okay, instead of 1 2 3, let us take 10 20. Okay, 10 20 30 40 50 60, like that, 100. Okay, 10 elements are there in our list. Okay, suppose the element to be searched, if it is a 65, okay, 65 is not in the list. Okay, in such case, we need not search till 100, till the last element. Once we find 70, okay, what is the meaning means, till we search 70, 65 is not available. Okay, and we reached 70, the list is ordered list. So there is no chance that 65 means finding 65 after 70. Okay, we can break the loop there itself. This is one advantage of ordered list search. Okay, when searching an ordered list sequentially, however, it is not necessary to search to the end of the list to determine whether the target element is in the list or not. We can stop when the target becomes less than or equal to the current element we are testing. So this is the advantage of using ordered list. Okay, so this is our these are all the different variations of the sequential search. Okay, and here the algorithm is given. Okay, now binary search. Okay, so what is the advantage of binary search? Okay, and what is the condition for binary search? Why we cannot use a sequential search for all the elements, all kind of a list? Okay, why means the sequential search algorithm is very slow compared to binary search. Okay, and suppose if we have 1000 elements, whatever the element we need to search, if it is in the 1000th index means we need to perform minimum 1000 comparisons. Suppose worst case scenario, whatever the element we are searching, if it is not in the list also, minimum we need to perform 1000 comparisons, worst case scenario. Okay, so these are all the disadvantages of a sequential search. Okay, and if the array is not sorted, we don't have any other option. We need to use the sequential search only. Okay, on the other hand, what we can do means, if the list also large and if it is not sorted means, we can perform the sorting operation first, then we can apply the binary search concept. Why we need to use a binary search concept means, compared to the sequential search, it is very fast and very efficient one. Okay, so now we are going to discuss about the binary search concept. Okay, in binary search, in each iteration, the entire list, okay, the entire list to be searched, it is divided into half. Okay, first, based on the value that we are looking, based on that, we will divide the list to be searched as a two halves. Okay, first half and second half. Based on the middle value, whether it is greater than the target or less than the target, we will perform the searching operation only in the first half or in the second half. Okay, so in this way, the binary search, in each iteration, it reduces the list size into half. So it's more efficient than the sequential search. Okay, see here, although the binary search starts by testing the data in the elements at the middle of the array to determine if the target is in the first or second half of the list. If it is in the first half, we need not check the second half, and if it is in the second half, we need not check the first half of the list. Okay, now let us take this example. In binary search, we will use the three variables: begin, end, and middle. Okay, all these three are index. Begin means the first index, end means index of the last element, and middle means index of the middle element. So this is what the meaning. Okay, so how to calculate middle element means, okay, add the begin index value plus end index value divided by 2, and then calculate the flooring. Okay, we need to round off to the previous integer. Okay, now let us take this successful binary search scenario, this illustration. Okay, here we have a list of elements. Okay, it contains some 12 elements. Here begin is zeroth index. The first index of the list is 0, and the last elements index is 11. End is 11. Now how to calculate the middle means, add 0 plus 11. So 11 divided by 2. When you are dividing 11 by 2 means you will get 5.5. So if you are rounding up after the previous integer means you will get 5 flooring. Okay, 5 is the middle index. Okay, so we will go to the fifth index. What is the fifth index value? 21. And what is the target value we need to check means 22. Okay, we need to compare this 21 and 22. 22 is greater than 21. So for sure 21 will not be available in the left hand side, means the first half of the list. Okay, it must be in the second half of the list only. Since 22 is greater than 21, okay, it must be in the second half of the list. Why means the list is a sorted list. Okay, for sure 22 must come after 21. So what we will do next means, we will change the beginning of the index. Okay, what is the beginning of the index in this case means the middle value plus 1. So middle value is a 5. 5 plus 1 is a 6. So 6 we will assume consider as the beginning of the list. See here, 6. Okay, now end of the list, no change, the same 11, and we need to calculate the middle. So 6 plus 11, 17. 17 divided by 2, 8.5. If you are rounding off the 8.5, you will get 8. Okay, so 8 is the middle value. Okay, now 8 is the eighth index, we have 62. Okay, but 62, it is larger than the target value 22. Okay, so for sure 22 must be in the left hand side, means within these three elements only the 22 must be. Okay, not in the right hand side, right half of the list. Okay, so in this case we are changing the end element, means the end index. Instead of 11 we are going to change it as a middle minus 1. Okay, so what is the middle value? 62. Its index is 8. Okay, so middle, that is a 8 minus 1 is a 7. So 7 we are going to consider as the end of the end index. Okay, so now begin, no change, 6, and end, no changes. End is changed from 11 to 7. Okay, now calculate the middle element. 6 plus 7, 13. 13 divided by 2, it is a 6.5. When you're rounding it off, you will get 6. Okay, so sixth index, what is the value we are having? 22. So if it is a 22, if it is equal to our target means, okay, if it is equal to our target means, forcefully we need to increase the begin value greater than the end value. Okay, we need to terminate the loop. What is the condition for the terminating loop means, begin must be greater than end. So we need to calculate begin equal to end plus 1. Okay, so begin equal to end plus 1. 7 plus 1 is 8. Okay, so the loop will terminate. Okay, whenever we are finding the target value, forcefully we need to increment the begin more than the end index, so the loop will be terminated. So this is an example for successful binary search. Okay, let us take the algorithm and check it once. Okay, see here, this is the algorithm. First we are setting the begin value to 0 and the end value to the last index of the list. Okay, and uh, we are starting the loop iteration. Loop begin it is less than or equal to end, then setting the middle value to begin plus end, okay, divided by 2, calculating the middle value begin plus end divided by 2. And if the target is greater than the middle element, if the target is greater than the middle element, we are moving the begin to middle plus 1. Suppose if the target is less than the middle element, then we are changing the end value from middle minus 1. Okay, we are changing it to middle minus 1. Suppose if it is not greater than, not less than, what is the meaning? Means target is equal to the middle. Okay, in such case we are forcefully incrementing the begin index to end plus 1. Okay, why we are doing this means then only the loop will break. Okay, otherwise here explicitly we can give break statement also. Okay, so that is we will use it in the C. Okay, since it is an algorithm, here we are how to break this loop forcefully. Just increment the begin value more than end value, begin equal to n plus 1. That's it, the loop will terminate. Once this loop is terminated, set the middle value to location, because in the middle value only the target element is available. So if target is equal to, the target is equal to middle means set found equal to true, otherwise set found equal to false. So this is the binary search algorithm. Okay, this is the binary search algorithm. Okay, and this is an example for unsuccessful binary search. Okay, here also the same way, the begin, middle value, end. Okay, the calculation is compared, and see here, begin, middle, end, in everything is pointing to 14, but 14 is not equal to our the target value 11. Okay, then in the next iteration what will happen means the begin value will be incremented by 1, so begin will become more than end, loop will terminated. Okay, so this is an illustration for the unsuccessful binary search. Okay, let us take an example here. The program, we will check it here. This is a binary search. Okay, so the program, the binary search program, the algorithm, okay, as it is implemented in the C. Okay, three variables declared: begin, middle, end. Begin initialized to 0 and end initialized to last, while the loop is implemented using while loop. While begin is less than end, calculating the middle equal to begin plus end divided by 2. Okay, if target is greater than the middle, begin equal to middle plus 1. Else if target is less than the middle, end equal to middle minus 1. Else begin equal to n plus 1. Okay, and a location. Okay, if target equal to middle means that is the target element and the middle element both are same, it will return 1, otherwise it will return 0. The return type of the algorithm is integer. Okay, and for the same input, whatever we used in the sequential search, the same main program we are using it here. Okay, and calling the binary search. Okay, here we are passing the list and the last element, index of the last element, target and location. Okay, let us check the output. Here in this list we are going to search for 20. Okay, 20 found at index 1. See here, 20 is available in the index 1. Suppose if I am having 200, okay, then 200 not found in the list. You can give all the inputs. Suppose if you want to search the last element, 60. Okay, let us check it. 60 found at index 5. Okay, 60 found at index 5. So 60 also available in the list. Okay, suppose if I want to search the first element, 10, I'm giving 10. Search it. See here, 10 found at index 0. 10 is also available in the list. So this is how we need to implement the binary search concept. Okay, so the sequential search and the binary search both are important searching concept. The next search is a hashed search. Okay, so hashed search we'll discuss in the next class. Before going to the hashed search, what is the efficiency of this algorithms? Okay, so here sequential search, the sequential search loop, whatever the loop we are implementing in the sequential search, it is more or less equal to the linear uh, loop, okay, linear iteration loop that we discussed in the algorithm analysis part. So its efficiency is a O of n. Okay, suppose if there are n elements there in the see list of element list of uh, numbers means then at least n iteration n comparisons or n iterations we need to perform. So that is what sequential search. And all the sequential search variations, sentinel search, probability search, ordered list search, everything will have the O of n only. Okay, we discussed about we discussed that the probability search, okay, it will improve the efficiency. Okay, even if it is improving the efficiency will become the coefficient, a constant coefficient before the efficiency. So as per the calculation of big O notations, we need to remove the constants and coefficients. So obviously it will become O of n. So all the sequential such variations, it will have the O of n as the uh, efficiency. And a binary search, in each iteration it reduces the list input list into half. Okay, it is a logarithmic progress. So binary search will take O of log n as a efficiency. A comparison table given here. Okay, if list size is 16, okay, then how much iterations, worst case, how much iterations binary search required, and how much iterations sequential search required. See here, if it is a list size is 16 means in sequential search we need perform 16 iterations, but binary search will take only 4 iterations. Okay, the list size and the sequential search size, okay, both are equal. Okay, O of n. Okay, but binary search, it is means very much less than the list size. It is a logarithmic process. So binary search is more efficient than the sequential search. Okay, so this is binary search and sequential search concept. Okay, so in the next class we will discuss about the hashed search hashed search concept. Okay, what is a hashed search, and in hashed search what are the problems are there, that is a collision resolution technique, what are the various collision resolution techniques available. So all these things we will discuss in the next class. Okay, now if you have any doubt you can post it in the yeah, already Sai Sudarshan asked one question, that is what if we have duplicate values. Okay, so explicitly if we are not writing an algorithm, uh, then the first element, okay, wherever the first element is available, then that element will be considered, will be treated as the element, because the algorithm, what is the searching algorithm means whether the element exists in the list or not. If it exists once or more than once, it doesn't matter. Okay, if it exists, it returns that index and it's true, search is successful and it returns true. Okay, otherwise it will return false. Okay, duplicate means based on the requirement of the algorithm. If the algorithm requires no duplicate, in such case we need to modify the algorithm like that. Okay, first we need to ensure that the list not contains duplicate values, then we need to perform the uh, yeah, searching operation. Okay, so this is what in case of duplicates. And in based in our last class, one student asked example for n factorial, O of n factorial efficiency. Okay, so here, so these are some of the examples. Okay, so in this website they have given example problems, okay, example scenarios for each of the uh, big O algorithm analysis. O of 1, O of log n, O of n, O of n log n, O of n square. When we will have O of n square means when finding all permutations of a given set. Okay, finding all permutations of a given array. Okay, for such scenario requires n factorial, O of n factorial uh, analysis time. If the list is not sorted, the time complexity of the binary search is O of n log n. Yes, correct. Because for sorting it takes some time, plus the binary search efficiency. Okay, so it includes O of of n log n. Any other doubts? We cannot use binary search with for the sorted or unsorted array. Okay, first we need to perform the sorting operation, then only it's possible to apply the binary search. Joshna, you are correct. Yes. Actually, we are telling the time complexity only for the searching operation, not for the sorting operation. Okay, only searching alone, if you are taking means, okay, we are assuming that even in the sequential search, okay, even the sequential search for the sorted array. Okay, if the array is sorted, okay, and the we are performing this sequential search means the worst case scenario. What is worst case scenario means the element not exist in the list. That requires minimum n comparisons. Suppose if the number of elements in the list is 10, suppose if the element is not available in the list, okay, minimum n comparisons we need to perform in the sequential search. Suppose if the element is greater than the last element, okay, so there is a worst case scenario in the sequential search. But in binary search, okay, in the sorted array, it is half of the efficiency. Okay, so in such case, so in this way binary search is efficient. Yes, Amritavalli. Okay, so number of iterations are getting reduced every time. So it means it is reduced dramatically, logarithmically. I'll share this PPT and this video and the example programs. What are the programs we discussed? That also in the classroom. Any doubt in today's class? Okay. If no doubt, we'll meet in the next class. Thank you.